Okay, so today we're going to be working through a two-function problem. So the beginning instructions have this graph, then it says, let f and g be defined by functions f of x and g of x. Let R and S be the two regions enclosed by the graph of f and g, shown in the figure above. So A says to find the sum of the areas of regions R and S. So because they switched, and this one's on top, then it's on bottom, and this one's on bottom, and this one's on top, we know we're going to have to do two separate integrals, so we need to find this midpoint. So to do that, we're going to take our graphing calculator, plug the two equations in, hit graph, we're going to do second calculate, then 5 for intersect. We're going to do the first curve, and the second curve. It's going to give us the point. 1.032, 2.401 for a midpoint. So then we're going to start working on the integrals for this. So to find R, we're going to be going from 0 to 1.032. And that is going to be the top, which is g of x. Minus f of x. Okay. Then we're also going to, now we have to get s too, so we want to find the sum of both of them. So we're going to do another integral, this time from 1.032, the midpoint, up to 2. This one's going to be f of x minus g of x, because this time fx is on top and g of x on the bottom, so it's upper minus lower. So when you go through this, and you plug these in to these and do the integrals through your calculator, you're going to go back and hit y equals, plug this in, it'll be g of x minus f of x. Take graph, second calculate, then we're going to do 7. We're going to go from 0, enter, 1.032, enter, and it's going to give you 0.997 for that one. We're going to do this one, same thing, put the f of x first this time, make sure you get your parentheses, minus g of x. We're going to do second, calculate 7 again, 1.032, enter 2, enter, and this one is going to give you 1.007. Add them together, you get your answer to be 2.004 for A.
So now we're going to work on part B, and part B states, region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. So find the volume of the solid. So really what this means is that the 3D model of this, there are squares coming out of it, so we're going to find the volume of those. So now I'll show you how to do that. So since we know it's squares, we know it's A equals S squared. So really what we're going to do is we're going to take the integrals of this. So take the integral and then we do it to 2 to the 1.03 2 that we had. And then we're just going to put in f of x minus g of x, and then parentheses, we're going to put that all together and then square it, and then that comes to that. So then for f of x and g of x, we're just going to plug in what we have originally in the equation, put that in for there, and then put g of x into there, and then that will get us an answer of 1.007, and then we're going to put that around parentheses because we still have to square it. And then once we square it, we get an answer of 1.014. And that's how you do that. So now we're going to do part C, and part C states, let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x when x equals 1.8. So now we can tell that we're dealing with the derivative, and our distance is 1.8. So now we're trying to find the rate at which h changes. So we're going to do so we're going to do h of x equals f of x minus g of x. but since we're gonna deal with the derivative, we're gonna take the prime of all these. So f prime of x minus g prime of x. Okay, and then we're gonna put our x in, which is 1.8. So this is just kind of like a step-by-step of how to do it. And then, so now we're gonna put this into our calculator. So once you put in f of x and g of x, you're gonna graph it. And then once you graph it, you're gonna do second trace. Then you're gonna go and hit 6. And then you're gonna go and enter in 1.8, enter, and you get 2.1162837. Now you're gonna do second trace again, 6, then move it down to get the other part of it and do 1.8 again, and you get 5.9280072. So now you're going to subtract these two, and then once you subtract the two, you'll get your h, or at the rate of which h changes, and so h then equals negative 3.182, and I just rounded to the third decimal point, and then this, remember, is the rate of which h changes.
So now that we're done with the problem, we did all A, B, and C. We're going to go through how we got points for this problem. So for A, the total is with 4 points. You get 1 point for considering the two limits. You get 1 point for each integral. So there's 3 already. Then we get 1 point for the answer. So we get plus 4 on this one. For B, you get 1 point for the integral. No, 2 points for the integral and 1 point for the answer. So you get 3 on this one. And for C, you get 1 point for considering h prime, which we did, and you get 1 point for the right answer. So this one is also plus 2. So we get all 9 points on this problem.